Hello kids, you're welcome to class. As you all know, the normal concept we normally use in solving problems in quantitative reasoning, which are addition, subtraction, multiplication, division, and this question will be looking at use of modular arithmetic. Here comes example 1. This is an analog wall clock whose number ranges from 1 to 12. And as you can see, the maximum number in a wall clock is 12. Because of that, we'll be operating in modulo 12, which is an SS1 topic in new general mathematics. How does this work? The concept is this. Whenever you're adding numbers together, the maximum answer you can ever have is 11. That is 11 and below. Anytime you have a number that is up to 12 or above 12, you need to subtract 12 from it because it is the modulo of which you are working with. Now let's look at number 1 question here. You say 9 plus 6 is equal to 3. Using our normal mathematical calculation, this 9 plus 6 is equal to 15 and not 3. What they did was that they added 9 and 6 together, which gave us 15. Then they now subtracted 12 from it, and you know 15 minus 12 is equal to 3. Let's go straight to our demonstration board for explanation. We have 9 plus 6, and 9 plus 6 gives us 15. Because we are operating in modulo 12, we'll now have it as 15 minus 12, and 15 minus 12 is equal to 3. That's how they got that 3. Okay, now looking at number 2, we have it to be 2 plus 7. 2 plus 7 we know is equal to 9. Now nothing changes here because 9 is not up to 12. So this one is acceptable because it falls below 12. Then the third one here, we have 4 minus 5 is equal to 11. How come? How come we're getting 4 minus 5 to be 11? Now, the concept used here is that whenever you are working with negative sign, what you need to do is that you have to move in an anti-clockwise direction. You know your wall clock, the minute, seconds, and hour hand of the wall clock normally move in a clockwise direction. But whenever you are having a negative sign, the direction of the movement will now be in an anti-clockwise direction. Then you start from the very first number, which is 4. Now we are having 4 here. It means that we are starting from 4. We'll move 5 times, which is the minus 5. Any number, the number where it ends at, that's the answer we're going to have. So let's go. We're starting from 4. Let's move. I'm moving 5 times because it's minus 5. Move 1, 2, 3, 4, and 5. We can all see that at the 5th movement it ends at 11. That's why 4 minus 5 is equal to 11. I guess that is clear. Now let's proceed to the 4th example here. We have it as 6 plus 7 is equal to 1. We all know that 6 plus 7 is equal to 13. What they did was that we have it as 13 minus 12 is equal to 1. That leads us straight to our demonstration board. We have it as 6 plus 7. 6 plus 7 gives us 13. Then 13 minus 12, which is the modulo we are working with, is equal to 1. So that's how the 1 was gotten. I guess it's very understandable. Using these concepts, you can solve any problem in modular arithmetic, be it plus or minus, provided you know the concept that is said to be what? Applicable, knowing when to go in the clockwise direction and when to go in the anti-clockwise direction. Thank you. Let's proceed to example number 2. Now, in example 2 here, we have a rectangular box which is divided into 9, and the numbers on it are 2, 4, 6, 4, 16, 20, and 6, 36, 42. In this question, the concept used was the application of two imaginary numbers, which are imaginary times 2 and imaginary plus 2. I'm talking about for that of the first horizontal number. I'm considering the horizontal numbers now. For 2, 4, and 6. What they did in the first place was just to multiply these 2, which is the first number, these 2, by 2, then add 2 to it. Then you know when you multiply 2 by 2, you're going to have 4. Then add your imaginary 2 to it, you're going to have 6. Let's go to our demonstration board for explanation. Now, assuming 6 was not given to us, how do we get our 6? Assuming 6 was not given to us, let's go to the demonstration board. We have it as 2 times imaginary 2 is equal to 4. Then 4 plus the imaginary 2 is equal to 6. So that's how 6 was gotten. Now, assuming 4 was not given, assuming this 4 was not given to us, what do? What we simply do is to say 6 minus 2. Let's proceed to our demonstration board. Assuming 4 was not given, what do? We easily say 6 minus 2, and 6 minus 2 is equal to 4. So that's how 4 was gotten. Then, assuming 2 was not given, assuming this 2 was not given, how do we get it? We just simply say 6 minus 4, and 6 minus 4 is equal to 2. Assuming 2 was not given, what do? We say 6 minus 4, and 6 minus 4 is equal to 2. So also, we'll move straight to that of the next example in the second row, which is row 2. Row 2 here, we have 4, 16, and 20. What did they do? The very first thing, they are working, what they do is that they are working with the first number, which is 4. We easily say 4 times imaginary 4 will give us 16. Then 16 plus imaginary 4 will give us 20. Now let's proceed to our demonstration board for explanation, assuming 20 was not given. I will know the very first number to be 4. The first number there is 4. Which is 4. We easily have it as 4 times imaginary 4, which is equal to 16. Then 16 plus imaginary 4 is equal to 20. So that's how 20 was gotten. Now, assuming 16 was not given to us, how do we get our 16? We easily say 20 minus 4 will give us 16. Let's proceed to our demonstration board. Now we have it. Assuming 16 was not given, what we simply do is to say 20 minus 4 is equal to 16. That's how it was gotten. And lastly, assuming 4 was not given to us. Assuming this 4 was not given to us, how do we get it? We simply say 20 minus 16. And 20 minus 16 is equal to 4. Let's proceed to our demonstration board. Assuming 4 was not given, what do we simply do? We simply say 20 minus 16. 20 minus 16 is equal to 4. So same applies to the last one. You just say 6. Assuming 42 was not given to us, what we simply do here is to say, assuming this 42 was not given, you just say 6, which is the first number, times 6 gives us 36. 36 plus 6 gives us 42. Then, assuming 36 was not given, what do we simply do? We just say 42 minus 6. That's what was gotten. Then, assuming 6 was not given, assuming this 6 was not given to us, what do? We simply say 42 minus 36 will give us 6. Guess that is very, very clear and simple. And lastly, we're having example number 3. What do we do in this kind of overshape? Now, for us to be able to get, it's just an addition. An addition of the top number and the bottom number gives us the middle number. That is to say, for us to be able to get this 11, we easily say 2 plus 9. And 2 plus 9 gives us 11. Let's proceed to our demonstration board. Assuming 11 was not given to us, what do we simply do? We add the top number and the bottom number together, which is 2 plus 9. And 2 plus 9 is equal to 11. That's how 11 was gotten. Now, assuming 9 was not given, how do we get our 9? Assuming this 9 was not given, what do? We easily say 11 minus 2. 11 minus 2 gives us what? 9. Let's move to our demonstration board. Assuming 9 was not given to us. Assuming 9 was not given, what do? We simply say 11 minus 2. 11 minus 2 is equal to 9. That's that. Then, the next one, assuming 2 was not given to us, what do? We simply say 11 minus 9 is equal to 2. Let's move straight to our demonstration board. Assuming 2 was not given to us. Assuming 2 was not given, what do we simply do? Say 11 minus 9 is equal to 2. Same applies to the numbers on this right hand side. Now, assuming 12 was not given to us, what do? We easily say 7 plus 5. And 7 plus 5 gives us 12. Let's proceed to our demonstration board. Now, assuming 12 was not given, what do we simply do? Say 7 plus 5 is equal to 12. That's how the 12 was gotten. Then, assuming 7 was not given to us, the 7 here, assuming it wasn't given, how do we get it? We easily say 12 minus 5 is equal to 7. Let's move straight to our demonstration board. Assuming 7 was not given, we simply say, for us to be able to get 7, we simply say 12 minus 5 is equal to 7. And lastly, assuming 5 was not given to us, the 5 here wasn't given to us, how do we get our 5? We easily say 12 minus 7 is equal to 5. Let's move to our demonstration board. Assuming 5 was not given. Assuming 5 was not given to us, what do we simply do? We simply say 12 minus 7 is equal to 5. So that's the end of today's lesson. I guess you enjoyed it. I guess you find it interesting. I hereby look forward to your outstanding performance in the quiz as well as the assignment. Do have a wonderful day. Bye.